Before we do, we are going to take a selfie. So for everyone walking in the room, even if you're walking, you can smile. And I have to set this up here. So we'll try to fit everyone in. Everyone try to squeeze together, make a smile face. Ready? 1, 2, 3, 4, 5. That's okay. I got 3 pictures.
All right, give yourselves a hand.
Thank you. Woo. Your homework starts now.
Yeah.
All right, I'm going to put this away. And now we're going to go ahead and move right into it. So first off, I am Jessica Dean. I am a cloud developer advocate here at Microsoft. A little bit about my background. My background is all Linux, open source, containers, which is convenient because I'm doing a containers talk, and IT operations. I also work on a DevOps-focused team, but I'm often asked why I don't have DevOps in the first bullet point. The reason why is because every single thing that I do, DevOps is implied. DevOps is more of a mindset, a culture, it's a choice, it's something I'm proactive in, and we're going to talk about why that's important today. Non-related to tech, I'm also super into CrossFit and fitness. Pretty much any city I go to, hotel I go to, continent, country, you name it, I will drop into a hotel gym or a CrossFit gym and usually end up scaring everybody in there because I'm upside down doing handstand push-ups or falling over after I get off the assault bike, all that fun stuff. I also am a huge Disney and Star Wars fan, and I don't say that lightly. I actually have Han Solo's blaster tattooed on me, Luke Skywalker's hilt. I have what I have been told is the most epic fandom crossover tattoo, complete with the Doctor Who, Gallifreyan language, Star Wars quotes, Princess Bride, Harry Potter, Zelda Master Sword, Lord of the Rings, you name it, I'm a geek. I am also a member of what we call the League of Extraordinary Cloud DevOps Advocates, or as we just refer to ourselves, the League. I'm going to talk a little bit more about that after I introduce Steven. Before I do, down at the bottom here, you can follow me on Twitter, Instagram, or GitHub at JLDean. No relation to James Dean, so my last name is spelled with 2 E's. And with that, I'm going to go ahead and let Steven introduce himself.
So, similar story to Jessica. I am not near the fan that she is of Star Wars, but I am a fan.
Most people aren't the fan.
Yep.
It's okay.
I am though sporting my Darth Vader socks.
He did that for me.
I did, and my background though is more on the ops side from the Windows background and open source as well. I've got a little boy at home, and I'm still married, at least as of this morning. And we'll see after the end of the week. And I'm also on the team with Jessica as part of the League.
So with that, let's go ahead and talk about the League. We are led by Donovan Brown, who you may have seen in yesterday's keynote. Hashtag black shirt, hashtag rub DevOps on it. We also have Abel Wang, we have Damian Brady, obviously Steven, and myself. But what I love most about this picture is that, first off, we are the DevOps Cloud Developer Advocacy team at Microsoft. But this picture really embodies and embraces and truly displays what DevOps is for us. So Abel, Damian, and Donovan all have primary developer backgrounds. Steven and I just introduced ourselves, and our backgrounds are very primary ops, or not traditional developer, but we would develop infrastructure now. So here you have developer and operations not only working together, but presenting together. Abel Wang and I did a presentation, which is a deep dive to this kind of content yesterday. And so I love this picture because it really kind of shows this no wall, no barrier, DevOps culture team working in effect. Also, if you ever have a question with anything related to DevOps or pretty much anything around Linux, open source, any one of our specialties, you can hashtag LOECDA on Twitter. It is literally like our bat signal. So yesterday, true story, I got asked, are you part of Donovan's bat team? You mean the League? Yes, bat signal, bat team. All of that, it sends a message to our Microsoft Teams room where it lights up and we know that you want to talk to somebody on our team, even if it's just to chat about Star Wars, have some fun, crack some jokes. I think I'm funnier than I probably am. It's fine. However, as awesome as the League is, we are only a small part of that awesome, amazing cloud developer advocacy team at Microsoft. The larger cloud developer advocates, or hashtag Azure Avengers, follow Azure Advocates on Twitter. There's about 60 of us worldwide, and we're growing. And the cool thing is we have people that specialize in everything, from high-scale big data, IoT, machine learning, AI, you name it, things that go way over my head for people that are way smarter than me. We have something for everyone on our team.
All the different language communities?
All the different language communities. It's cool because we're also, since we're located around the world, we cover every time zone, every language, every continent. It's awesome, and it's awesome to work for this team. But without further ado, you guys are obviously here in a room to learn about containers, DevOps, all this stuff in Azure, right? We keep hearing the word containers, we keep hearing Azure. Let's get started. Before we get started, though, we do have to talk about the current state of technology and the current state of our industry. We are going digital. This is a slide that is produced with data from a Gartner study a few years ago. They estimated that by 2020, 1 million devices per hour would be coming online. I'm just going to repeat that. 1 million devices coming online by 2020. It's 2018, and it's almost June. That's in less than 2 years. That's a lot of devices. They also estimated that by the same year, the average age of an S&P 500 corporation would be 12 years of age. Compare that to the 1960s, when the average age was 60 years old. Companies are getting younger. They're spinning up quicker. We have more and more devices coming online. And then the last statistic, 60% of computing would be done in the public cloud by 2025. It's about 7 years away. It's not that far. And we're already seeing such a shift to the cloud. So I actually would argue that that percentage is a little low. You have everybody talking about the cloud. Your grandmother talks about the cloud. But when she does it, she uses air quotes. Now, fun story about the cloud. I was in Paris in March presenting at Tech Summit Paris. And I had breakfast at this little cafe, and I noticed that the table next to me actually spoke English. So I got really excited because my French is awful. So I leaned over and I started exchanging conversation and tried to figure out where they were from and what they're doing there. The daughter was on spring break and vacation from college, and they were just coming to Paris. So they asked what I was doing. I said, well, I work for Microsoft, I travel, and I speak. They're like, oh my gosh, do you know where the cloud is? And I laughed. I was like, actually, I do know where the cloud is. It's in Azure. And they're like, no, that's wrong. I looked at them. They're like, I'm going to tell everyone I know where the cloud is, and I met the cloud, and the cloud's name is Jessica. I'm like, OK, that's awesome. That's a funny story, but it's true, right? Everyone's talking about the cloud. But what does that mean? So let's talk first about what we're hearing and why this matters, why the cloud matters. Out of everyone in this room, and I know we're at a developer conference, I know this is Build, how many people would identify themselves as a developer? Okay. How many people would identify themselves as IT or operations, maybe? Okay.
Oh, awesome.
So that's actually more than I expected, but that's great. So for the developers in the room, or even operations, even if you kind of are a jack of all trades, you wear multiple hats, tell me if this sounds familiar. I need to create applications at a competitive rate without worrying about IT. My applications run smoothly on my machine, but when it hits your server, they break. It's your problem. It's not mine. Or my productivity and application innovation become suspended when I have to wait on you. You, IT person, are the bottleneck to my success. Don't worry, IT, I'm getting to you. You guys get your moment, too. Here you go, developers. Ready? This is what we think. I need to manage servers and maintain compliance without disruption. I can't just give you access to RDP and do whatever you want with my servers. But I'm also not a developer, so I'm unsure of how to integrate this kind of application. I need to work with you. I need you to teach me and help me understand so we can fix this. But I'm also unable to focus on both server protection and application compliance. I can't worry about the security of my servers and the security of your app. Sound familiar? Mm-hmm. Regardless of where you fall in this technology field, and I know this says IT stress points, I'm not just talking to IT. I'm talking to every single person in this room. If you touch software, if you use it for either standing up infrastructure or you write code, you do something with it, these are your stress points, right? You have to worry about security. You have to worry about efficiency. And you have to worry about supporting this innovation that we just talked about in the Gartner slide. So that's why cloud is important, because cloud is a new way to kind of think about data center, right? The traditional model was that you had dedicated infrastructure for each application. The hardware you had was purpose-built for that project. The infrastructure and operations teams were distinct and separated. I often use an analogy of it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room. No one wants to come together and hang out. But what you also have to realize, it's a choice to stay on either side of the room. And then the processes and configurations you had were customized, and they were specific to each project. But that model isn't scalable. It can't grow. It can't support that rapid innovation and that momentum that we've already started picking up. So that's why the cloud model is important. Now you have loosely coupled apps and microservices. The hardware is now industry standard, right? Azure is your computer. The DevOps teams that you have are service-focused DevOps teams. You're now hearing multiple companies, let's implement DevOps. Let's break that wall down. Let's have people make the choice to come into the center of the dance floor. And the processes and configurations you have are standardized instead of customized. So that really sets the stage for DevOps. And DevOps will set the stage for containers, and it's going to be cyclical. We're going to talk about it. So it starts with people. We know that because we just talked about it, developers and IT. And then we have to go through a process, right? There has to be something that's standardized across the board that can be repeatable, that can be recyclable. And then we go into products. Now, my boss, actually, Donovan Brown, was the one who wrote this particular quote. You might have seen little Dono dude floating around. I think it's so cute. I love it. But let me just read this to you. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Now, a lot of people have seen this quote, but not a lot of people know that Donovan spent 30 days writing it because he wanted to make sure that every single word in that quote was something that he could stand behind, was something that the team and the league that he leads could stand behind. We're specific when we use the word products. Why not tools? Well, when you think about it in building a house, I can have a screwdriver, I can have a hammer, I can have a miter saw, I can have all these tools. But without products and process and the right people, I'm not going to be able to produce anything of value. I can't build a house. So here's that plan that we talked about. It starts with planning. It starts with having an idea. And then you have to go into your develop and test. This is your routine. This is that cyclical, we're keeping things moving. But that's part of your development stage. And then as you start getting over into release or your deployment stage, anything that would happen in your CD process, that's where you're starting to get over into production or whatever your end environment would be. Your dev environment, your QA, your staging, canary, prod. All of that needs to still be repeatable no matter where it lives. And then the fourth and most important is the ability to monitor and learn. Can I get rich telemetry so I can figure out, am I delivering value to my end users? Standard DevOps practices. You have infrastructure as code. We're going to talk about that. That's key when it comes to containers. You have continuous integration, or your build. We'll demo that today. You have automated testing, continuous deployment, your release management. Your continuous deployment happens as part of your release management, right? You wire up this pipeline. Everything's cyclical. Everything keeps moving. You have app performance and monitoring, load testing and autoscale. All of these practices can fit in those 4 different buckets that keep your machine running like a well-oiled machine. Benefits of implementing DevOps, and this is even from a few years ago from Puppet, but you're able to have a strong IT performance and competitive advantage. Firms who have implemented DevOps practices were 2 times as likely to exceed their profitability. Most importantly, for everybody in this room, think of it from this perspective. You're able to deploy code 30 times faster with 200 times shorter lead time. You're also estimated to have 60 times fewer failures. And in the event of a failure, you can recover 168 times faster. That's huge. So now we've talked about DevOps. We've talked about these practices. We've talked about the current state of our industry. Why is that important when it comes to containers? You're going to start seeing how containers builds on those practices. Before we do, I'm going to make you guys laugh again, or I hope you're going to laugh. This was a video that we recorded at KubeCon Austin. The guy in the video with me is Eric St. Martin. I show this in every container talk I do because from a very high level, it explains basic container orchestration. To prove it, before we finished recording, or technically right after we wrapped, we went through about 8 takes. And at about the 5th or 6th take, there was a woman who kind of stood off to the side while we were filming. She had been at KubeCon all week. She was just one of the volunteers. She said, I've been here all week. I don't know what you guys do. I don't even know how to say this word Kubernetes or what. She stumbled through it. She said, but I think after watching your video, I understand. It's that things are reliable. When something fails, it's still up. It's still available. Yes, that's what we wanted you to understand. I sent the same video to my aunt because I send her pretty much everything I do. And I get the same response every time. I still don't understand. Are you speaking English? Which is still funny, but I still send it to her. And she ended up replying, by the way, this is the level of her technical understanding. When she says that she's going to send a text, she says, send me a bubble, which is just adorable. Hashtag send me a bubble. But I sent it to her, and she said the same thing. She said, so when something fails, it's still going to work. Yes, that's the basic of it. That's the basis of it. So let's go ahead and watch this video. It's less than 2 minutes. Hi, my name is Jessica Dean, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got green screen and an amazing producer.
This is some really good virtualization.
So
what are we doing today?
We are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. Bad Docker file. Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers, especially for the sake of time.
There we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Gotta be efficient. Always efficient. Look at all these apps we're deploying. This is gonna be the best node ever. I'm so excited for this node. Look at this. So pretty. I can't wait to see this node done. This is gonna be my favorite node ever.
Best one. Hey Zach.
What's up, man? What are you guys doing?
We're talking about container orchestration.
Yeah, we just deployed a node on the server. We just deployed a bunch of apps.
I really need. Do you mind if I?
Well, actually, now we have node failure. What are we gonna do?
I don't know.
We actually have a Kubernetes cluster.
That's right.
So, want to see what happens when?
Yeah. So let's go over to our other node. Look at that. Thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second node. This is fantastic.
It's magic.
I really hope that this helps explain how orchestration works. Thanks for watching, social media. And thanks for watching, Seattle. Everyone can laugh. I do not mind being laughed at. I actually said that yesterday on Channel 9 after I did a really crazy dance. She's like, you know I own this footage and I'm going to post it. I said, that's what I expected. So again, that video is meant to be funny, but it's also serious. You'll notice certain things I said we're going to talk about in some of these slides. So why containers? Remember the pain points that we talked about earlier for developers in IT? Containers enables this write once, run anywhere mindset. It enables microservice architecture. And it's great for dev tests of applications and services, but it's also production realism. For operations, the biggest benefit is portability, portability, portability. You're now able to have standardized development, QA, prod, all these different environments. And with containers, your runtime environment is encapsulated. So if it works in dev and QA, it's going to work in prod because everything's nice and neatly bundled. And we'll talk about how that works. So for some of the people in the room, you might still be new to containers. You've heard the word, but you're still not 100% sure what a container actually is. So what is a container? First off, containers is operating system virtualization. Very simply put. Traditional virtual machines is hardware virtualization. You also have Windows Server containers, which will give you maximum speed and density. And then even with Windows and Hyper-V containers, you also get isolation and performance, because now you've isolated the kernel with the container. But that still doesn't explain what a container is. I'm going to blow people's minds. It's not a real thing. It is an application delivery mechanism with process isolation, and it's actually based on several Linux features. So a lot of these words are things that you'll hear in association with orchestration tools like Kubernetes. You'll hear namespaces. That's what a process can see. You might even hear C groups. That's what a process can use. So that's things like memory and CPU and devices. Namespaces gives you access to PIDs and mounts and network and, again, users and C groups. Now I always get asked is, OK, so process isolation, starting to understand, but then what is Docker? You keep talking about Kubernetes, and you keep talking about all these other tools and containers. How does Docker fit into it? Why do I need a Docker file? First off, Docker is an open source container runtime. It has Mac, Windows, and Linux support. It is a command line tool as well. So you have a GUI, but you can do Docker commands. And then the Docker file format is used for building container images. The Docker image format uses also a layered file system. So we'll talk about that, especially with caching layers. So here's what a simple Docker file looks like. And it might look scary, especially for any IT pros in the room or developers who have never written it. We're going to talk about not only how to create this, but with how to create it without writing one single line of code. And Steven's actually going to demo that in a second. Yeah. So first off, you have a Docker file. You have your structure. You're doing from. You're doing a command, whether I want to copy, whether I want to add, whatever I want to do. And then I can run a command, and that would ultimately end up creating my hello world Docker file application, which when I run it at the bottom would just give me hello back. That's all it's going to give me. But that's a Docker file. But here's how this is working. So Docker, as I mentioned, uses a layered file system. So you kind of take a base image. So in this case, it's based on Ubuntu's 15.04 image. And then you have all these layers that are kind of cached on top of it, all these different parts that's needed for this image. And these are read-only layers. But where read-write ends up happening sits on top of the flattened layers. So you'll notice when you're going through your build, when you have a Docker file and it says it's building and pushing an image, it's going to say it's building and it's pulling this layer and it's pushing that layer. Those are layers and caches that it sits, so it makes it easier to manage. Now let's take a look at what virtualization versus containerization looks like. So traditional virtualization, you have two different types, right? You have hardware with your hypervisor sitting on top of it and VMs. You might think of that like VMware, ESX, or ESXi. Or you can think of it like maybe with hardware, host OS, hypervisor, VM sitting on top of it, perhaps Hyper-V and Windows Server. And then you have the guest OS and dependencies and application, and it's a lot to manage. But with containerization, you have hardware, you have your host operating system, you have the Docker engine that sits on top of that, any dependencies sit on top of your engine, and then you have little kind of containers on top of that. And what a container is made up of is your app dependencies, that's also layers that it pulls, and then your application itself. And all of that's defined as part of your Docker file. So again, we still talked about these problems and pain points that developers and IT pros have, right? So here's why containers are important. Here's the advantage of using containers. You have fast iteration. It's agile delivery. You have immutability. You have cost savings, efficient deployment, and elastic bursting. And elastic bursting is where you can go from private cloud, if you're running a private instance of Kubernetes or private cluster, and actually burst into public cloud based on CPU demand. So that solves issues for both developers and for IT, right? It's trying to meet those additional requirements or the additional needs. So now I mentioned that Steven's going to show a demo of how to create a Docker file without writing one single line of code. So I'm going to go ahead and switch over to him real quick.
There we go. All right. So I'm going to show, I've got VS Code open here, and I've got a little Node.js app. It's a pretty basic Node.js app, but I'm going to do some local dev work like I do. And when I'm doing my local dev work, I like to be able to run my app, do debugging, that kind of thing. And let's just make sure that everything all works. So I just hit F5. And it looks like we got things running. Let's see if my app runs. Hey, that's some pretty fancy ASCII art.
By the way, that's using a Node app, and the dependency is Figlet. It turns all your text into ASCII. And I'm a huge fan of anything ASCII and binary, so much so that I have binary tattoos tattooed on me. Told you I'm a geek.
All right, so hey, nothing special about being able to run a Node.js app locally. But we want to take advantage of containers, right? We want to take advantage so we can get a lot of the benefits that Jessica was talking about, and so we can start playing around and trying this stuff. Well, VS Code has some stuff to help me. So there's an extension. There's a Docker extension in the marketplace. I've already got it installed. I also have Docker for Windows installed on this machine. And with that extension, I can go to my command palette and start typing Docker. And I want to add Docker files to this workspace. Now, there's actually a bunch of languages supported by default. Go, Java, .NET. We've got Node.js. Let's see what that does for us. What port does my app listen on? 3000. That sounds good. It's almost like that was
planned.
Set, yeah. Funny how that happens.
We wrote it port 3000, so we entered it. And look at that. It actually added the Docker file and even some Docker Compose files.
Yep. So there's a couple of files that were added. Didn't have to do much of anything. But now that I've got these Docker files here, what can I do with them? Well, I can spin up my app, and just to let you see here, there's these two Docker Compose files. There's a Docker Compose.debug YAML and a Docker Compose YAML. The debug YAML is the important one here. This is so I can actually run my app in a container and get local debugging, so that I'm going to run like I'm going to run in production, but I also have my same local dev experience. So to get that started,
and again, just to clarify, he didn't write one line of code. That was from the Docker extension.
I'm going to use the command palette again, and there's a Docker Compose up. It lets me pick the Compose file I want to use. I'm going to spin up the debug one.
So you don't have to know that command line. It entered it for him.
Yep. And what it did is it built my container and started running it on my local Docker instance. So now I have a container running, and now I want to start debugging. So we go over to our nice little bug picture here, and I'm going to move this over so we can see. Now, it says no configurations, and in order to debug into a container, I have to create a configuration so that the debugger knows where to go. So I'm going to add configuration. And one of the first suggestions it has for me is Docker attached to Node. So all I have to do is hit enter, save, and I'm ready to debug into my container. So I can pick Docker attached to Node, start debugging.
And while that's loading, that functionality for him to add that in was added in and provided again from the Docker extension. That's not anything that's a keystroke or anything on our end. It's the Docker extension for VS Code.
So I'm going to set a breakpoint right before the Figlet call. So when I refresh my browser, then I should get my browser spinning, and I should see the breakpoint being entered, right? So let's see what happens.
And I see it flashing right down there. So what happens when we click on it?
Let's see. All right. We are now debugging the application running in the container. So
built from the image that the Docker file for VS Code created for us.
Yep. And we have access to local variables. We have the call stack, all the experiences that we would normally have when we're debugging locally.
So that part's really cool. It shows us, OK, we can take this application that we're used to working in our dev experience. I kind of want to start learning this container stuff. I want to start doing these DevOps things, but I don't know where to start. So VS Code will create the Docker file for me. I've now done, as a dev, I've done all my local debugging. I know that this app is now working in my Docker file. I feel proud. I didn't have to write one line of this Docker container mumbo jumbo. But now how do I get it into the cloud? How do I run it in Azure? How do I use these DevOps practices that you've been talking about? So to set myself up for this, I'm going to add this stuff into my repository. So I'm going to commit this while Jessica starts to take us down deeper into what we're going to run. Do you want to show us the git commit from VS Code? Well, I'm a command line guy. As am I. Hashtag no clicky clicky. So just basic git commands, right? We're going to add our files. We're going to add a commit message, and then we're going to go ahead and push. Yep. So that's it. So it's up in GitHub. It's not linked up to any kind of CI/CD pipeline. We're going to show you that in the next demo. But the first thing we want to do is we want to make sure that we talk about container orchestration before we dive deep. So here's elements of container orchestration. First off, Kubernetes is not the only orchestrator. You have DCOS, Mesosphere, you had Docker, Docker Swarm, Swarm Mode, there's Pivotal Cloud Foundry. There's all these different orchestrators, right? What makes up an orchestrator? Elements of orchestration. You have scheduling, you have affinity, anti-infinity, health monitoring, failover, scaling, service discovery, networking, coordinated app upgrades. Tell me if any of these words fit into those buckets of standard DevOps practices that I talked about earlier. Starting to see the connection here, how things are linking. But we are going to talk about Kubernetes because it is the de facto orchestrator. Why? First off, it's portable. You can use it public, you can use it private, you can use it in hybrid instances, you can even use it in multi-cloud instances. It's extensible, meaning it's modular, it's pluggable. It's also self-healing. When you use a managed instance of Kubernetes, right? You can have auto placement, you can have auto restart, auto replication, auto scaling, which is really nice. It empowers you to do more. So what do I mean by that? First off, you can deploy your applications quickly and predictably. You can also scale your applications on the fly. So a lot of the things that go back to Kubernetes is you're starting to implement things like infrastructure as code. You start having these YAML files and these deployment files and these service files. Everything's repeatable and recyclable. As such, you can roll out features seamlessly. You can also limit hardware usage to required resources only. Because remember, we talked about container advantages. It has access to the C groups. It can see the hardware. It can see CPU. It can see memory. I can define that as part of my deployment. So let's dive even deeper into container orchestration, focusing on Kubernetes. First off, what is it? Flat out, Kubernetes is an open source container orchestrator that automates the deployment, scaling, and management of applications. It was originally written by Google. Yes, I'm at a Microsoft developer conference talking about something that was written by Google. Mind blown. It was donated to the Cloud Native Foundation. As of March of this year, it was the first project to graduate from the Cloud Native Foundation. And on top of that, it's the only project, as of right now, to have graduated from the Cloud Native Foundation. If you want to learn more about the requirements of that, you can go to cncf.com. But more so, it also has really awesome features. You have automatic bin packing. Remember my video? I kept saying, let's get our bin packing in order. You have self-healing. You have horizontal scaling. You have service discovery, load balancing, rollouts, rollbacks, right? Load balancing, networking. You have secret and configuration management. So we'll talk a little bit about Kubernetes secrets, but that allows me to store, let's say, Docker registry information so that I don't have to exchange username and password in my deployment files, and I can just reference an image pull secret that's attached to a namespace that's attached to a deployment. So that way, the deployment can have access to my private registry. And we'll show a little bit about that. Why should I care about Kubernetes? Why should I use it? First off, it's agile. So you have 8 servers down here at the bottom. You have your little container orchestrator space. Here's where the containers go. Here's your happy little IT, dev, whatever kind of tech person you have. You have all these apps that you want to move over into a container orchestrator. We want to keep this person happy. Because it's agile, we're able to move it easily over into the orchestrator, and it's spaced out over our workers, over our nodes. But it's also scalable. What happens if I have more applications? I want to add more servers. Especially when I'm using a managed Kubernetes service, with one command, I can add 10 more nodes, 50 more nodes, 100 more nodes for my workers. As such, when I have more apps that I want to move in that container space, it makes it super simple to scale. And most importantly, it's reliable. So in the event I do have nodes that go down, it's self-healing. It'll spin up new workers. It'll spin up new nodes. And I don't have to worry about my apps failing. That was that funny part of the video, right? The IT person came over, messed everything up like we usually do. I was giving you one, devs. So now you might be wondering, where can I run Kubernetes? There's a variety of different options. Cloud is not the only option. You can do Minikube, which is an open source project available on GitHub. You can even use Docker. The latest Docker Edge for Windows or Mac includes the ability to set up a Kubernetes cluster locally on your system. You can do cloud. You can do Azure. We have several different options. You'll notice we have more than the others. You have Azure Container Service, or ACS. That would be an unmanaged instance, and we'll talk about that. You have Azure Kubernetes Service, which is AKS. You also have Azure Container Instances, which is backed, by the way, for those who don't know, with Kubernetes. Then you have AWS for Elastic Container Service, Google Cloud Platform, or Google Kubernetes Engine, commonly referred to as GCP or GKE. But we're going to talk about Azure and AKS. It is your Kubernetes cluster, and it is managed by us. That means that we take care of the control plane. We take care of the master nodes, and we'll talk about what that looks like. Why AKS? First off, it's easy to use. It is the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. And I argue it's technically 2 if you already have kubectl installed on your local system. It's also easy to manage. You have automated upgrades and patching. I mentioned how it's easy to scale and move from 8 nodes maybe to 18 nodes to 50 to 100, however many you want. You can easily scale the cluster up and down with 1 command. It's also a self-healing control plane. It also uses open APIs. This is 100% upstream Kubernetes. This isn't a forked off branch that Microsoft owned and decided to do some crazy stuff with. This is 100% upstream Kubernetes. Here's how easy it is to get started with AKS. Like I said, literally 3 commands, technically 2. The first command is using, by the way, all of these commands is using Azure command line. So that's also free and open source and cross-platform. You can go download it. But you would run AZ AKS create. You specify your resource group name. You specify the name of your cluster. And you can even use the flag to generate SSH keys, so you don't have to provide one. It'll do everything else. And by default, when you run this, you'll get 3 nodes. It sets up 3 workers for you. Then if you don't have kubectl, which would be the local command line tool to interact and communicate with your Kubernetes cluster, you can simply run AZ AKS install CLI, and we'll install the CLI for you. And the final command is AZ AKS get credentials. Again, specify your resource group name and your cluster name. And that'll actually download your config or your context onto your local system so you can communicate with your Kubernetes cluster. And if you already have additional Kubernetes clusters in other clouds or locally on your system, it's just going to merge your context. It's not going to override anything. And then you're able to interact and get your nodes and start talking to your Kubernetes cluster. But I also mentioned it's really easy to manage. So the first command, I can run AZ AKS list, output is table, unless you're really adamant on reading JSON. But you can actually see the Kubernetes release that's running. If I wanted to upgrade to perhaps a different release, a different version, I can do that again right from command line with a flag. And as of yesterday, they showed in the keynote how you can actually do that even from the portal. I can go in and GUI and click if I wanted to. Again, my hashtag is no clicky clicky. But then again, I can see that when I run the kubectl get nodes, my version has been upgraded. I went from 177 to 181. And then when I mentioned how easy it is to scale with 1 command, again, you just use the AZ AKS scale command with an agent count flag. How many agents do I want? 10, 50, 100? However many you're willing to buy, I promise you, Azure wants to give them to you. But why would I care about AKS versus ACS? This is essentially ACS. This is without AKS, without the managed version. You're responsible for the control plane, which includes the master VMs. That also means you're paying for them. And you're responsible for your agent pool, all the workers, all the nodes. So you're responsible for your hardware upgrades, canonical upgrades, patching, Kubernetes, anything. You're responsible for all of it. But when we manage it, we take care of the control plane. You don't pay for it. All you have to worry about is this. So from developers and IT, it empowers you and encourages you to where all you have to focus is what's running in your cluster. So we take a lot of the legwork out of you, and you can focus back on delivering that continuous delivery of value to your end users. So now we mentioned that we're going to talk about DevOps pipelines and how to set up this connection to Kubernetes, right? We have the app that Steven created earlier with the debug file or the debug Docker file. But I want to run that in Kubernetes. I now know how to set up my cluster, but how do I also do all these DevOps practices that I've talked about, right? So Steven's actually going to show me how to do that.
All right. So because we want to do this in a scalable, automated way as a good DevOps citizen, we want to create a CI/CD pipeline for this. So I'm in my portal for Visual Studio Team Services, and I'm going to walk through, along with Jessica here, creating a full CI/CD pipeline for deploying a container running my little Figlet app into a Kubernetes cluster on Azure. So we're going to start out, create a project, and we're going to call it Jessica Teaches Steve Containers.
Great. So it looks like actually Visual Studio is setting up this project for us, right? It's going to set up source control repo where we have access to this. We have access to work dashboards,
work items, and it's going to have our harness for our build and deployment.
Okay.
And really get us set up for success.
So that was really fast.
Yep. Yeah, it usually goes pretty quickly.
And it looks like we actually have quite a few options for how we would want to get code in here. It looks like we can push from an existing repository that we would have on our system. We can import a repository, because as I understand it, Visual Studio Team Services actually gives us free, unlimited private repos.
Oh, yeah.
So I don't have to pay GitHub $8 a month.
You do not.
Yes. I really need to save $96 a year.
So, but our code does live in GitHub. So
we did that intentional, by the way. If you guys want to actually fork the same demo we're using, you can go fork it because it's out on a public GitHub repository.
So we're going to set up our build. And we have some options for the source. And we're going to go to GitHub. So it needs access. And I need to give it a connection name. We'll just call it demo. And I'm going to authorize it with OAuth. Now, I've signed into GitHub before, so it just picked that up, and I said it could do this before, so it's fine.
That's really fast. Now, what happens if I have a lot of repos in my GitHub? Is that going to take a while to find?
It could, potentially, but there's a handy little thing here. Click on the ellipsis, and we have a filter. So I have a lot of repos as well. And let's go and find our Node app. There we go.
Cool.
And it picks a master branch. You can tell it different branches to build. I'm going to build master because I like trunk-based development.
Now, okay, again, I'm still new. Do I have to know what I'm doing as far as tasks or anything, or is there a template for me?
There are templates. There's templates for a lot of different build types, but since we're dealing with containers, let's take a look. And we have a container build type. So I'm going to apply that template.
Okay. So it looks like it actually added in the build and push task for me, because this is just a task runner on the left-hand side here.
Yep.
But what's this agent queue?
So the agent queue is where the builders are.
Okay.
And by default, Visual Studio Team Services offers a number of hosted ones where they build and manage, or they manage them for you.
So these are computers that are going to run my build.
Yep. And
Cool.
you can also have private build queues, and we'll talk about those in just a minute.
So Microsoft Visual Studio Team Services gives me a hosted Linux preview.
And hosted Mac if you want it. But we're building Linux containers, so let's use the Linux preview.
Okay.
All right. Now we can dive into our tasks. So the first thing that we need to do is build an image. Now, in our repository, we committed our Docker file, right?
Yep.
So we are going to use the Docker task here to take advantage of that, build it, and push it to my Azure Container Registry.
Awesome.
So first thing we have to do is authorize one of my Azure subscriptions.
That has access to the Azure Container Registry, right?
Yep.
Okay.
So I'm going to click authorize, and it's going to go in the background, and it's going to create my service principals and all the authentication stuff that my build is going to need to communicate with that, and set it up so that Docker knows how to actually push to my container
I don't
registry.
have to then add any kind of username or password information to connect to this registry?
Nope.
Okay. Oh, look at that. So I can actually choose a registry.
Yep. We're going to pick my SJM demo.
Okay. And I see the action, because I used a template, the action was already pre-selected for building an image.
Yep. And by default, it's got a glob on the search there, so it's going to look through your repository for your Docker file.
Okay.
I like to be a little more specific about it.
Yeah,
so I'm going to
explicit is
go
always
in,
better.
and so yeah, I don't like unexpected stuff happening in my builds. So I'm going to go pick what I want.
And now this is obviously very simple. I'm just getting started. I don't know build arguments, so I see VSTS is actually already checked using the default build context. It's entered in image names with variables that it's set up for me, and I see qualify image name. That's good. Now, I see that it's going to push with the build ID. I can just, rather than entering latest tag, I can just check a box.
Yep.
That's cool.
And it's a common pattern in the container world to whatever your latest image is, to add the latest tag as well. So it makes it a handy, easy way to grab whatever the latest is.
That's awesome. So now going over to pushing an image, do I have to go read through and recreate that service principal and that reauthorization?
Nope. We'll just grab it so we can see available service connections.
Awesome. So this is going to make it a lot faster.
That it will.
Okay. And then I see the Azure Container Registry. Now it also, just like in the build, since I used a template, already has push an image as the action. I don't have to change the image name, and all I have to do is check a box for latest tag.
Yep.
So I'm ready to go.
We are ready to go.
All right, so if we hit save and queue, it's going to actually pop up with one more final box where it just allows us to confirm, do we want to use our agent queue? You can also use private agents, and while this is building, we'll talk about why you might want to. So he just queued off a build, and when we click the build, we can actually watch. So remember we talked about Docker files. We talked about layers and caching and pulling all those different layers, right? Right now, this is a very simple Docker file, right? It's a simple node app, hello world, essentially. It has one dependency of Figlet. There's not a lot of layers. But once you start getting into more complex workloads, and actually Abel and I did a session yesterday where we kind of deep dove into this. I did a recording of different container images on demand Channel 9 videos. And I demo bigger files where some of these builds can take 7 minutes or more because it's pulling so many different layers. And since this build agent is ephemeral, it's not going to cache that and be available for the next build. So in that instance, you might want to look at private agents so that it can cache those layers and make sure that each subsequent build is going to go nice and fast. Now, in this instance, because it is a very small Docker file, there's not a lot of layers, this build actually ran really quickly in about 30 seconds. Yep. But now we want to take what we just pushed up into the cloud. We still need to get it over into Azure. We now have it off our machine. The image is now up in the cloud, up in Azure Container Registry. We need it in Kubernetes. So it looks like right from within VSTS, we can hit release.
We can. And that's going to go and start scaffolding out our release process.
So our release management. Again, remember the DevOps practices we talked about earlier, release management, continuous deployment. So in build, I could select a template. Can I do the same thing for release?
Well, let's see. Well, we're in luck. So
looks like I can.
So let's see what that gives us there, right?
So glad that exists. So now for environment, I can just name my environment as I would, right? Like probably dev?
Dev, yeah.
Perfect, OK. So now I know that this is kind of bigger because we had to blow up the screen to make sure people in the back could see. But on the left-hand side for artifacts, we didn't actually hand off any artifacts over to release. There's no files we need for this. Again, in my demo yesterday with Abel, that was on best practices for Kubernetes, we did have things that we're handing off. But in this instance, we want to pull it from Azure Container Registry. Can that be an artifact?
It can. So what we have to do is remove this artifact, and then we can add a new one. And basically what the artifact is that's going to be the trigger for us to do our release management. So it's going to monitor the Azure Container Registry for us. And when there's new versions of the container that we're going to specify, then it will kick off a new release.
Cool. So it looks like we can actually select our registry, select the repository. We don't have to do anything with source alias. And if we just hit add, that adds it in as our artifact.
Yep. And I didn't have to re-auth. So that first time I connected to my particular
container registry and subscription?
My subscription, yeah. It's sharing that context throughout this whole process.
Awesome. Now, what's this little lightning bolt?
Oh.
So that's our continuous deployment trigger. So that's going to actually fire off the continuous deployment. So after we have this all wired up, anytime we make changes, we push to our Azure Container Registry, or we do a git push, because our build is actually listening, it's going to fire off the build, and now it's going to automatically trigger this release. That's pretty neat.
So we got that turned
But now
on.
we have to define the tasks, right?
We do.
OK. So when we click in there, so again, I see we've already named the environment. Under agent phase, do we have to choose our agent again?
We do. So by default, it's going to go to that hosted Visual Studio 2017.
But we'll want to make it match just our build, so we'll go ahead and do the hosted Linux.
So let's scroll up to that. There we
go.
All
right. And so now I see kubectl apply. Now, for anyone in the room who's still new to Kubernetes, you would probably use kubectl apply and then some sort of YAML file to apply